Isaac Newton stands as one of the most influential figures in human history, a man whose revolutionary discoveries fundamentally transformed our understanding of the natural world. Born in an era of scientific awakening, Newton's contributions to mathematics, physics, and astronomy laid the groundwork for the modern scientific age and continue to shape our comprehension of the universe today. Isaac Newton was born on January 4, 1643, in Woolsthorpe Manor, a small farmhouse in Lincolnshire, England. According to the Julian calendar used in England at the time, his birth date was December 25, 1642. His birth was remarkably precarious. He was born prematurely and so small that his mother, Hannah Ayscough Newton, reportedly said he could fit into a quart mug. His father, also named Isaac Newton, had died 3 months before his birth, leaving the family in modest circumstances. When Newton was 3 years old, his mother remarried Barnabas Smith, a wealthy rector from a nearby village. The marriage arrangement required Hannah to leave young Isaac with his maternal grandmother, Marjorie Ayscough. This separation profoundly affected Newton, creating deep-seated feelings of abandonment and insecurity that would influence his personality throughout his life. He developed into a solitary, introspective child with intense emotional reactions and a tendency toward obsessive behavior. Newton's early education began at local dame schools before he attended the King's School in Grantham at age 12. Here he lodged with the local apothecary, William Clark, where he was first exposed to the world of chemistry and medicine. Newton proved to be an indifferent student initially, more interested in mechanical devices and inventions than traditional studies. He built sundials, water clocks, and even a windmill powered by a mouse running on a wheel. A turning point came when Newton was beaten by a school bully. Determined to prove his superiority, he not only physically confronted his tormentor, but also resolved to surpass him academically. This competitive drive propelled him to the top of his class. However, his mother withdrew him from school in 1659, intending for him to manage the family farm. Newton proved utterly incompetent as a farmer, spending his time reading under trees instead of tending to agricultural duties. Recognizing his academic potential, his uncle William Ayscough and headmaster Henry Stokes convinced Hannah to allow Isaac to return to school to prepare for university. In June 1661, Newton entered Trinity College, Cambridge, as a subcisar, a student who performed menial tasks to pay for his education. The curriculum at Cambridge was still largely medieval, focusing on Aristotelian philosophy and traditional mathematical texts. However, Newton's voracious intellectual curiosity led him beyond the prescribed studies. He began reading the works of modern philosophers and mathematicians, including René Descartes, Pierre Gassendi, Thomas Hobbes, and Robert Boyle. The plague years of 1665 to 1666 forced Cambridge to close, sending Newton back to Woolsthorpe. These 18 months, which Newton later called his annus mirabilis, miraculous year, proved to be the most productive period of his life. During this time, he made groundbreaking discoveries in 3 major areas that would define his career: calculus, optics, and gravitation. In mathematics, Newton developed what he called the method of fluxions, now known as calculus. This powerful mathematical tool allowed him to calculate rates of change and areas under curves, providing the foundation for much of modern mathematics and physics. Working independently, Gottfried Wilhelm Leibniz developed similar methods around the same time, leading to a bitter priority dispute later in life. His experiments with optics began when he purchased a prism at a country fair. In his darkened room at Woolsthorpe, Newton discovered that white light was not pure, but composed of all colors of the spectrum. By passing sunlight through a prism, and then through a second prism, he demonstrated that white light could be separated into colors and then recombined. This discovery revolutionized the understanding of light and color, overturning centuries of accepted wisdom. Perhaps most famously, Newton began formulating his law of universal gravitation during this period. The popular story of an apple falling from a tree inspiring his thoughts about gravity, while possibly apocryphal, contains essential truth. Newton realized that the same force that caused objects to fall to Earth might also keep the Moon in its orbit around Earth. Newton returned to Cambridge in 1667, earning his Master of Arts degree and becoming a Fellow of Trinity College. In 1669, his mathematics professor Isaac Barrow resigned his Lucasian professorship in favor of Newton, making the 26-year-old one of the youngest professors in Cambridge's history. Newton's first major work focused on optics. He built the first practical reflecting telescope, using mirrors instead of lenses to avoid the color distortion plaguing refracting telescopes. This invention brought him to the attention of the Royal Society of London, and he was elected as a Fellow in 1672. His first paper to the Royal Society, describing his experiments with light and colors, generated significant controversy. Robert Hooke, the Society's experimental curator, criticized Newton's conclusions, beginning a lifelong rivalry between the two men. The contentious reception of his optical work made Newton extremely reluctant to publish his research. He developed an almost pathological aversion to criticism and controversy, preferring to keep his discoveries private rather than face public scrutiny. This tendency toward secrecy would characterize much of his career. The turning point came in 1684, when Edmund Halley visited Newton at Cambridge to discuss the problem of planetary motion. When Halley asked what curve a planet would follow if attracted to the Sun by a force inversely proportional to the square of the distance, Newton immediately replied that it would be an ellipse. When pressed for proof, Newton promised to send it later. This casual conversation led to Newton's greatest work. Encouraged by Halley, Newton began writing what would become the Philosophia Naturalis Principia Mathematica, Mathematical Principles of Natural Philosophy. Working with obsessive intensity for nearly 2 years, Newton completed this monumental work in 1686. The Principia, as it's commonly known, presented Newton's 3 laws of motion and his law of universal gravitation, explaining everything from the motion of projectiles to the orbits of planets and comets. The first law states that objects at rest stay at rest, and objects in motion continue in uniform motion unless acted upon by an external force. The second law quantifies force as the product of mass and acceleration, F ma. The third law declares that for every action, there is an equal and opposite reaction. The law of universal gravitation states that every particle of matter attracts every other particle with a force proportional to the product of their masses and inversely proportional to the square of the distance between them. This single law explained terrestrial gravity, planetary motion, tides, and the precession of the equinoxes. The publication of the Principia in 1687 established Newton as the preeminent natural philosopher of his age. However, his later years were marked by significant changes in both his interests and circumstances. The political turmoil following James II's attempts to Catholicize England drew Newton into public affairs. As a committed Protestant, he opposed the king's policies and was elected to represent Cambridge University in the Convention Parliament that invited William of Orange to take the throne. In 1696, Newton left Cambridge to become Warden of the Royal Mint in London. This appointment, initially seen as a sinecure, became a serious commitment under Newton's leadership. He reformed England's currency, oversaw the great recoinage that replaced worn and clipped silver coins, and vigorously prosecuted counterfeiters. His meticulous attention to detail and administrative abilities proved as remarkable as his scientific genius. Newton was knighted by Queen Anne in 1705, becoming Sir Isaac Newton, the first scientist to receive this honor for his scientific work. In 1703, he was elected President of the Royal Society, a position he held until his death, using his authority to settle scientific disputes and promote experimental philosophy. However, these later years were also marked by bitter controversies. The priority dispute with Leibniz over the invention of calculus consumed much of Newton's energy in his later years. Newton's supporters accused Leibniz of plagiarism, while continental mathematicians defended Leibniz's independent discovery. The controversy split the mathematical community along national lines and hindered the development of mathematics in England for generations. Newton also engaged in heated disputes with other scientists, including John Flamsteed, the Astronomer Royal, over astronomical observations, and with Gottfried Leibniz over the nature of space and time. These conflicts revealed Newton's combative personality and his inability to tolerate criticism or competition. While Newton's scientific achievements brought him fame, he devoted enormous energy to pursuits that seemed inconsistent with his rational, mathematical approach to natural philosophy. He spent decades studying alchemy, conducting secret experiments in his laboratory, and accumulating one of the largest alchemical libraries in Europe. Newton believed that alchemical knowledge could unlock the secrets of matter and provide insights into God's design of the universe. Similarly, Newton invested tremendous effort in biblical scholarship and theology. As a secret anti-Trinitarian, he rejected the doctrine of the Trinity, believing it corrupted true Christianity. He studied ancient texts, calculated biblical chronologies, and interpreted prophecies. Newton saw his scientific work as revealing God's design in creation and believed that natural philosophy and theology were ultimately unified. These seemingly eccentric interests were not separate from Newton's science, but integral to his worldview. He believed that ancient wisdom, divine revelation, and mathematical analysis all pointed toward the same truths about the structure of reality. Newton's health began declining in the 1720s. He suffered from kidney stones and other ailments, but remained mentally sharp. On March 20th, 1727, Newton died in London at age 84. His funeral was attended by nobility, scientists, and dignitaries, and he was buried in Westminster Abbey, unprecedented honor for a scientist. Newton's impact on human thought cannot be overstated. The Newtonian worldview dominated scientific thinking for over 2 centuries, providing a mechanical, mathematical framework for understanding natural phenomena. His methods established the paradigm for modern physics: careful observation, mathematical analysis, and experimental verification. Newton's influence extended far beyond science. Enlightenment philosophers like Voltaire saw Newtonian science as proof that reason could unlock nature's secrets. The success of Newton's mathematical approach to physics inspired attempts to apply similar methods to economics, politics, and human behavior. Even after Einstein's relativity and quantum mechanics revealed the limitations of Newtonian physics, Newton's achievements remained foundational. His laws still govern most practical engineering applications, and his mathematical methods remain essential tools. More importantly, Newton established the principle that the universe operates according to discoverable, mathematical laws, the foundation of all modern science. Isaac Newton transformed humanity's understanding of the natural world through sheer intellectual power, obsessive dedication, and revolutionary insight. His legacy as perhaps history's greatest scientist remains secure, not just for his discoveries, but for establishing the very framework through which we continue to explore and understand our universe. In his own words, "If I have seen further, it is by standing on the shoulders of giants." Yet Newton himself became the giant upon whose shoulders all subsequent science has stood. Newton's personality, as complex as his scientific achievements, reflected the contradictions of genius. He was simultaneously humble and arrogant, generous with his insights yet fiercely protective of his priority. His intense focus and perfectionism, while driving his extraordinary discoveries, also fueled bitter feuds and periods of isolation. Modern scholars recognize that Newton's psychological makeup, his obsessiveness, secrecy, and emotional volatility were inextricably linked to his scientific creativity, making him both a towering intellectual figure and a deeply human, flawed individual whose personal struggles paradoxically contributed to his unprecedented achievements. Thanks for watching. If you enjoyed this video, please like, share, comment, and subscribe to the channel for more engaging historical content.